Good morning, everyone. Today is 17th February. I got some message on my messenger, LinkedIn Messenger, that why not I'm starting my design principle discussion or design discussion and architecture discussion because they are eagerly waiting for it. Sorry for making you wait. Actually, small just information kind of things here. My writing pad has little bit infrastructure problem right now, so I just ordered few item from Amazon, but somehow it got delayed. I thought that it will reach soon, but there are some circumstantial delay, and I hope that by coming Monday probably I will get it. So after that I can able to use my writing pad, and I think design and architecture decision is better done by that. I mean sketches and design that will make more understanding. So that's why I'm waiting for this. But meanwhile, let's me share you the normally, I mean the content which is publicly available, and some good book content also. Like today I'm just trying to share one good author's thought on design principle, and this is from the very renowned book. So you can assume that this is a some fundamentally good point they have mentioned in this chapter. So without delaying, let's start it. Okay. So here in this chapter, author is primarily mentioning that majorly four important points to be considered while discussing the principles of software designs. The first is problem partitioning. Author has explained these things below. So for now, just understand that these four points are problem partitioning, abstraction, modularity, and the fourth one has actually two things, but these two are different way of thinking, but the things are only one. So top down and bottom up strategy. And both cannot be applied, only one can be applied at one time. So either you go by top down approach or bottom up approach. Let's start with problem partitioning. So what is problem partitioning? By listening this sentence or word, you can easily understand that we are talking about the partition of problem. Why we need it? As per the author, like if you want to understand problem better, simple, testable format, modifiable, maintain and expand, then you have to do the partitioning of your problem so that it is easy to understand. It becomes very simple. The solution is easy to test. Solution is easy to modify and expand, and your solution is easy to maintain, right? Now let's try to understand. So this is the basic reason behind problem partitioning. This is the one of the good way to start understanding the required design for certain problems, right? This is what they have suggested, author has suggested, right? Please note here, author has mentioned in the bold line that as the number of partition increase, cost of partition and complexity both increased. So let me try to give you one example to understand this point. Many of us have worked on synchronous and asynchronous system, right? Synchronous system is sequential system, right? You have to execute step by step. So in that case, the complexity is limited in terms of like you don't have to manage the order, sequence, their results. You don't have to patch those results because it is in sequence. Like you started one step, you will complete first that step, get back the result, then start the next step and so on and so forth. So there is no challenge in integrating these solutions, right? But imagine the situation where your solution is having asynchronous concept. Now, suppose you want to execute. So in synchronous case, you have executed 5 steps, step 1, step 2, step 3, step 4, and step 5. You don't bother of integration much because it is a sequential. You first finish the 1, then 2, then 3, and then 4, and then 5. Finally, whatever result you will get, you should return. But in asynchronous case, what is the challenge? That you have started all the 5 together. Now you have to put the logic where these kind of system, independent system, if they need some data to be shared between the different sub-problems, for that you need some mechanism to handle something like shared buffer, shared concept. Like somehow you need to create some infrastructure to share these kind of attributes from one task to another task while going all these 5 tasks together, right? And this is very challenging because at critical regions section, at one point of time, you can work on one sub problems only, right? Other sub problems has to wait and so on and so forth. Like these kind of synchronization complexity will increase. Another thing is like patching of and stitching of all these sub problem result together and produce the final solution. So these are the things they increased in there, and that is what author has mentioned here. Okay, so I think fair enough to understand now the problem partitioning concept, and it's a generic point, right? So anything, whenever you get any problem, try to understand that problem very granular level, because once you understand the every puzzle, every part of the puzzle, you will able to solve the puzzle better way, right? That is what they have mentioned, author have mentioned here. Another point is abstraction. Now, author has mentioned here that an abstraction is a tool that enables the designer to consider a component at an abstract level without bothering about the internal, that's a definition. So forget that definition, just go ahead with, there are two common abstraction mechanisms followed usually, right? One is functional, which is the logic, business logic, and another is data. So primarily, your complete logic is working on two factors, right? One is their business logic and another is data. And this is those person who have worked earlier in any kind of like model view controller kind of system, like where model and controller are equivalent, view is silent. In those scenario, we will see that this is 2 point is very much meaningful, right? These 2 points like functional abstraction and data abstraction are very, very meaningful, right? So when I talk about the functional abstraction, it is like a module is specified by the method it performs. The details of the algorithm to accomplish the function are not visible to the user of the function. Now the point is, okay, so one more point I have mentioned, I have forget about, I don't know, author has mentioned, yeah. So here you have to perceive like when you want to solve your problem at a generic level, you have to create abstraction, so that abstraction will allow you to tweak your implementation in better way. Or as an example, let's try to understand one example through some example. As an architect, your task is to design some log mechanism, and the requirement is this log will work together to write at different kind of method. Like I mean to say, suppose you want to write your log on console, you want to write your log on log file, you want to write your log on database, you want to write your log on cache. So all these are different mechanisms, right? Maybe some cloud storage places, you want to write some log file and put it on some cloud database, something like that, okay? Or maybe if you want to further define, then like you want to write your log in NoSQL database, some standard NoSQL database on cloud, something like that. So now you have not one system, right? You have a multiple system where you want to write your log. That kind of situation, that kind of problem requirement cannot be handled without creating abstraction, because if you don't create abstraction, you will see that lots of duplicate things you are doing for multiple requirement, and which is actually making your design very complex and very unmaintainable, right? Very less maintainable. So this is what this is what abstraction is providing to you. So abstraction is a powerful tool, but at the same time, I would like to emphasize here that sometimes abstraction is creating performance issue. So it's like I would say that in fair understanding that abstraction is good utility, but using abstraction is also very much required to understand that what kind of impact you will get on performance. So you have to do the brainstorming over how much performance you want and how much maintainable code you want. What would be the life cycle of this functionality? If it is, changing very frequently, then you will have to understand the performance is primary goal here. But if you think that this code lifespan is very big, this is the central core component kind of things, then in that case, better manageable code is more priority on the performance. Of course, performance should be at certain significant level. There should not be like very poor performance. But yes, that's why I'm saying that architect role is balancing out. Okay, so you have to balance out and put your reason why you are taking decision for X, not Y. And this justification, if you put it properly in right, you should write always your perspective in the decision. So, but these things, in industry, I can see that these kind of things are lacking mostly. But this is what required in your design document. And if you are a good architect, if you are a good thoughtful person in architecture, you should always focus on these things, right? And the similar way is data abstraction is again abstraction kind of things only, right? So I think I am able to give you the gist of abstraction. Let's move on. And the third point is modularity. Please note this. These all are the author's thought. I'm just explaining you here this thought to you. But when I have a separate approach to explain these things with code and proper example, proper design, proper support of my sketches. So that will come in later video when I will try to explain on my way. But for now, I'm just sharing you these things as per the author's approach, the current author approach, which I'm reading the content, right? So here the modularity, meaning modularity specifies to the division of software into separate modules. So in the nutshell, if I would try to understand quickly the modularity which is considered by this author. The desirable properties of a modular system is, okay, so let's try to understand this way. Every module, I mean, when you divide your system in modular approach, it has an advantage in parallel development or something like parallel attention, parallel solving to, I mean, assigning to multiple people who can solve parallelly, like that thing. Okay. So, and how it started, like it started very old. I mean, when we have even not the object oriented concept, it's like modular programming language, just like C, right? Where you are implementing one function for one, I mean, feature implementation, right? Or one algorithm you are implemented in one module, like that. Later it comes to the people have started module as a set of features in bigger design. So like design considered as a complete architecture, and that architecture is divided into different components, and one component may cater multiple modules or may be uniquely mapped with certain, I mean, one module, one component, like that. But these are the words which is primarily not fixed at all, right? I mean, somebody can share that component means module, somebody will tell you that no, one component can hold multiple module, and so on and so forth. So it depends how you are presenting, right? And how you are perceiving. But whatever decision you are taking, if you are writing it as an architect, then that would be understandable for further reading, right? If someone will come tomorrow and he will read this paper or this design doc, they can easily understand, okay, modularity means this, and this author has, or this architect has written it in this way. Okay, so that is the way to explain your thought to others. But here modularity means you have to define a big solution into small solution, and that is module for this big solution, different modules which together work for solving this big problem. Okay, so desirable of modularity is each module is a well-defined system that can be used with other applications. Each module has a single specified objective, and module can be separately compiled and saved in the library. Modules should be easier to use than in build. Modules are simpler for outside than inside. Okay, so lots of theory, but anyway, simple to understand that every module is the smallest granular problem solution, basically. One problem solution like a specific objective, single specific objective, like that. Anyway, so this is more meaningful, and if you remember, SRP will happily playing here single responsivity problem principle. Okay. Now, advantage and disadvantage of modularity. In this topic, we will discuss various advantages and disadvantages of modularity. So let's go to first advantage of modularity, what the author thought here. So there are several advantages of modularity. It allows large programs to be written by several or different people, as I mentioned earlier also, right? And then it encourages to creation of commonly used routine to be placed in the library and used for other programs. It simplifies the overlay procedure of loading a large program into a main storage. It provides more checkpoints to measure progress. It provides framework to complete testing, more accessible to test. It provides the well-designed and more readable program. So these are the advantages of modularity, right? Disadvantages of modularity. Okay, so there are so many disadvantages as per author. Let's see. So there are several disadvantages of modularity. Execution time may be, but not certainly longer. So they're saying that due to the modularity, maybe your execution time increased. So they are just creating some doubt on this, that when you are understanding this modularity, how it is important, and what kind of level of modularity you will design in your system. It depends on like performance and other factor also to think on, and that's why architect's role is very, very challenging. I mean, one thing is thinking in all direction. Another thing, important thing is balancing out of these kind of concepts, because balancing out is the one of the key reason architect is an architect. So the second thing is storage size perhaps, but is not certainly increased. Okay, compilation and loading time may be longer. Okay, then inter-module communication problems may be increased. This seems significant to me, because if you divide in multiple modules, when you have only one module, probably there is no communication challenge, right? But if you have a multiple module, and so that will create communication problems between these modules, and that is not problem, but it's a challenging one, because making synchronization among the module is the challenge over there, right? What should you react? What kind of, behavior between these components? What should impact when one module is changed to on others? What they perceive, how they are observing to each other, those kind of things. We have to see in this division. Like this may be a good also, and this may be a bad also, right? So balancing out is very important. All right, so I think this much is modularity. Let's go forward now, and I can see that modular design reduces the design complexity and result in easier and faster implementation by allowing parallel development of various parts of a system. So this is kind of like partitioning also, the same thing happening, like you are breaking the problem into a granular level so that you can implement and you can test, you can modify, you can extend easily, right? So these kind of things is there. All right, so when I talk about the modular design, so it's different. What exactly thought process behind it? So it has multiple thought process. Let's first understand the how modular design is helping to achieve the functional independence. Functional independence is achieved by developing functions that perform only one kind of task and do not excessively interact with other modules. Independence is important because it makes implementation more accessible and faster. Now, the functional independence is a good design feature which ensures software quality on the basis of two major factors, cohesion and coupling. So I'm sure that all experienced guys here can understand that how your design is primarily evaluated based on cohesion and coupling. And especially if I talk about the object-oriented design, where you are designing the class, how you are designing the class, how you are designing multiple classes inside the module, inside the component, and how they are behaving and interacting to each other, what kind of behavior these objects play together, how much cohesion in your component or system, how much coupling in your system within system. So these kind of factors is very important to primarily evaluate your design, overall design quality. So in thumb rule principle, as a thumb rule, you can assume that higher the cohesion and lower the coupling would be considered a better quality of your design. Okay. I will come with the example and sketches later in my discussion, but for now I think author has mentioned it to just share you the understanding of what is cohesion and why cohesion and coupling is the major criteria used for measuring the quality. The second thing is, first is functional independence, please note it, and the second is information hiding. The fundamental of information hiding suggests that modules can be characterized by the design decisions that protect from the others. That is, in other words, modules should be specified that data included within a module is inaccessible to other modules that do not need for such information. The use of information hiding as design criteria for modular system provides the most significant benefits when modifications are required during testing and later during software maintenance. This is because as most data and procedures are hidden from other parts of the software. So I'm wrapping up this book chapter discussion today here only, and let me try to move on now coding part. Okay, so let's move on to the coding section now. Maybe today I will pick some lead code problem and solve it quickly. Okay, thank you. See you in the coding part now. Thank you.